Hi, my name is Michael Arroyo. I'm one of the lead developers for the BluSapphire cybersecurity platform. I'm also the creator and lead developer for BluGenie. BluGenie is a PowerShell-driven framework for threat hunting, data analysis, and remote administration. Let's check out some of the functions. In this session, we're going to discuss one of the main functions in BluGenie, and that's the Get BluGenieChildItemList, or Get BG-ChildItemList. So, Get BluGenieChildItemList is a file query. We can query file information, hash information, permissions, security checks, all of that information using regex patterns. So why don't we walk through that real quick. So we're going to do a quick search using getBG-ChildItemList, and here we're going to actually use search path parameter. So search path and path. Search path has an alias path, but search path we're actually going to use, let's say we use the variable env_window/temp, so the Windows temp directory. We're actually going to do a filter type. So filter type actually has a few different properties to filter through. So let's just look at that real quick. So we have ADS, which is a true/false. ADS including all information. So this is including all is an extended meta. So you're going to get a lot more information, and I'll show you what that is. A lot more filled in property fields when you're looking for this data. Now, mind you, the more information you're searching for, the longer it takes to query, right? And that's just how it runs. By default, filter type is actually name. So it only queries name, so it's the fastest possible search that you can gather. But we have hash information, hash including more meta, name including more meta, and path, type information, and then you're back at ADS. So here we're going to actually pull the name so we can show what the default property searches are, or default property instances are. And then we're also going to, so what are we doing here? We got bgchildinfo, search for the temp directory, filter type, and then pattern. So in this instance, by default, pattern is regex, and it would normally look like this. So dot is any character, and then asterisk is asterisk in regex means not lazy. Any commands after the first command continue to search through, so this is more or less a wildcard. So the pattern is going to be any file in that directory, Windows temp, and at this point we're going to, because we're interactive with the console, we're going to actually send that session right to the foreground. So in this instance, we're going to do out on escape JSON so we can verify that we're actually searching for that information and we can view what data is left behind. So here we do a quick search. Okay, so now we have the return. We can see that we found 10 files. Here we have more search information, so you can see parameter set results. We had a search path. These are the parameters that you sent to that command, so this is good for troubleshooting at some other time. Elapsed time, it took 11 seconds. Parsed file, so it parsed 10 files. It found 10 files. And here you can see there's identifiers. So each one of the main headers here, or child nodes rather, you have permissions, streams, name. So the name was a log file, short name. You can see how owner information is missing, signature description is missing, target information, extension, so on and so forth. You can see that there's a handful of metadata that's not being captured, and that's because by default, when you're doing a Windows, when you're doing a search for a file, this is the information that comes back the fastest. And so we're actually doing that pull. If you're only looking for a file name, we're allowing it to pull and parse data at the quickest speed possible. So if you go through all of these, you can see all the files, their full path, their full name, full path, last write time, the type information, ADS equals false. Any attributes, there's none right now because we didn't grab that, and nothing was removed. And it just did that for every file that we have here. Now, there's going to be two things that we're going to do to this list. We can actually shorten this query up using a new pattern. So if we look back at our original pattern list, we were actually looking for anything. Here we can actually look for, let's say we want to see any executables and any text files in that folder. So in this instance, again, we're doing regex. So we want to escape the character period, and we want it to be a real period, not a wildcard character as in regex. And we're going to do text. We're going to put the pipe command in to do or, and then we're also going to add, again, another item, which is escape character.exe. So this instance, we're actually looking for both text files and exes in this list. And before we were only looking for the name, but now we're going to do name include all. So this is actually going to give us a full list of metadata. And we'll describe, there's actually a few other options that are not captured in here, but we'll go through that in a second. So here we're going to run that same report. Okay, so we have the return data, and we can see that this time we found 4 items. But you notice that we still parsed 10 files. Now, this one actually took 31 seconds to actually process. And the reason it took a little longer is because we were actually processing more metadata. If you notice, our filter type is now name include all. So if we actually go up to one of the instances, one of the files, you'll notice that permissions and streams are still unidentified. But the name of the file is there, the short name file is there, and then we have stuff like full name, signature here. So last write time, creation time UTC, the type, last access type, link type, the hash information of that file. ADS still is false, creation time, last access time in UTC, last write time in UTC, and attributes. And so you can see that our metadata is much more precise, and we have a little bit more information than we first requested. Now again, scanning permissions for permissions and signature takes a lot longer to process that, and that's the reason why those are actually separate parameters. So if you wanted to do a signature check and you wanted to do a permissions check, they are just as easy as adding permissions as the parameter and signature as the parameter. And so now when you execute that same query, you're now going to get a full permissions catalog and all the signature information from those files. So here we're going to run that real quick. So here's our return data, and you can see again we found 4 files, but if you notice up here on the elapsed time, we're now actually pushing 41 seconds to query those files. And obviously we're looking for more data from the file information. So the more information we're looking for, the more or the longer it takes to process that info. And so if we go up, you'll notice now the permissions actually has the permission array or list actually has permission identification in it. So here you can see built-in administrators has full control, the system has full control. And then we also process the signature check. So if you look at signature version information, signature date, we also want to find signature company. So we can see the signature company was sysinternals, sysinternals.com. Was signature verified? It was signed. So we do have the signature information for each one of those files. So this executable processed with no problem. We also were looking at a text file. So here you can see short path, Windows temp sample.txt. You can see that there's an ADS actually, so there's an alternate data stream on this file. The file equals true. You can see the stream content of that file. So both there's a name content and a name. So the name is actually hidden data. The content of that hidden data is this string. This is a hidden message in ADS. And here's another one, name posh code, and you can see that there's a actual get hash info, so a command that was processing for Notepad trying to pull the hash information on that ADS stream. So this metadata is very insightful, grabs a lot of information. Here's the permissions again for that file. But here you'll notice that there is no, here's the signature date. But here when you're looking for signature verified, it says the file was unsigned. Okay, so now let's say we want to query for the hash information. So previously, we were scanning for a pattern of string, so it's .text.exe, and we were doing the include name include all. So the filter type was actually on the name object. The return was including extra meta. The pattern was looking for text or exes. We outputted that information as unescaped JSON to the foreground. We were looking for the permissions and we were looking for the signature. Here, let's say we want to search for a file that has a specific hash value. We can actually start a new command and we'll do the get BluGenieChildItemList. Again, search path. Here we'll just use the default Windows temp. We know the variable path works. We're also going to do the filter type. So the filter type this time is going to be hash. And we don't necessarily need the extra meta information. So we don't need all of that processing. We really don't care. What we're looking for now is a hash pattern that tells us that there is a rogue or an ADS, a possible file with an ADS stream on there. So that's causing us havoc, right? So here we're actually going to look for the hash. And here we're going to do a pattern with a default string. So in regex, this is the string. If any character is, if this validation set, if this string is somewhere found in another hash value, it will pull. If you want to make sure that this is more or less an equals, you want your hash value to have the caret return, so shift 6 as the starting character, and as the last character is going to be $. So this means the beginning of the string and of the end of the string, you want to have this text. This means equals. So we guarantee that we're only looking for these hash values. We did our filter type of hash, so those are the queries that pattern is going to look at, or that's the object rather that it's going to look at. We're not looking for extended meta, so it's going to be a quicker search. Now, we just returned extra meta. So we turned tons of different things, elapsed time, how many files were found, how many files were parsed. Let's say we did not need that information. We only wanted to know the full names of where those files are that are captured. So as quick as possible the search and as small as possible the results. Here we can actually do a return object on the command. And that return object can now give us just the object data, just those properties with just the object with the properties that we needed. And we can actually pull that out just like any other object in PowerShell. And so we can do a select object, property full name. So now when we run this command, we should see a scan of anything in C Windows Temp that has that hash pattern value found that's equal to only, and then we're only going to see the full file name path and nothing else. We're not going to see the extended information, the extended file information. So here if we hit enter and then we watch this process, we can see that the search was as fast as possible. It was a lot quicker. Actually, it was very familiar to, or very similar to the name call, because you're not looking for permissions, you're not looking for signatures, and you're not looking for the extended file meta. And here we did a return of the object only, so do not give me anything else. I don't need short path, long path, the name, when the file was created, none of that. We returned it as an object, and we filtered that object to only give us the property of full name. And we found that two files, notepad.exe and C Windows Temp, which doesn't make sense because notepad.exe should not exist in C Windows and C Windows Temp. And then sample.txt is also in that folder, and they both have the same hash value. So it looks like sample.txt was renamed to notepad.exe. So in this instance, we were able to query a specific hash value, an equal to hash value, and find the files that we were requesting. So let's say we were scanning a bigger directory. We were doing a recursive search. We're looking at hundreds of thousands of files. And currently, by default, BluGenie or BluGenieChildItemList uses memory. So for resource management, for managing all of its file properties, all of its captured data, it has a variable, and then that variable, or an array, and then that array is then updated with each and every object instance. Now, if you're looking through hundreds of files and it either finds all those files, or or it finds every file because that's what you queried. You used the wildcard to grab every file that's possibly found on the system, capturing that into memory. So that is a lot of memory overhead. It will slow down the box for sure. What we want to do is actually save that information, cache that information to disk, to utilize the as little memory as possible. So for that instance, we're actually going to go back and query the file name item, including all meta. We're also going to look for the permissions and the signature. But in this case, we're going to do, we'll do output escape JSON as well. But in this case, we're actually going to use the parameter useCache. So by default, useCache path is a GUID that's generated based on the command at runtime of the command. It's a GUID, a 25 string character string GUID, and it's saved to the C Windows temp directory. You can change that path by using cache path, and you can change it to another path if you like. So let's say you just wanted to do to the user's temp directory, it will save it there. But right now, we're actually going to save it to the C Windows temp by default. We're going to use its cache path. That cache information is saved as YAML format. So clean, very readable text to the local machine. When all of the objects are completed and the reporting is finalizing, it goes and grabs that YAML, the multiple YAML documents that are embedded into the single log file, and it creates a return. And then the return is captured one time and put into the report and reported back to the remote machine, or in this manner out to our foreground of output escape JSON. So we're actually going to do that full query again, but this time we're actually also going to leave pattern alone and allow it to capture all files, because pattern by default without a parameter, as I mentioned earlier, is everything. And we're going to run this. But actually I'm going to add recurse as well. So there's an option. You can actually also do recursive searches. So for this instance, we're actually going to do a recursive search because we want as much data as possible. We want to see how much data this is going to capture, and to pretty much note how much memory you're saving because you're caching all of this to disk. So like I said, the file is being saved to cwindows temp. So here, let's open that directory up real quick. You'll see that a new file was just created with a GUID.log. If we open it up, you can see permissions. Permissions are being captured. The file is notepad.exe. It's getting us that information. Here is the YAML new document identification, which is 3 hyphens, and then permissions again. And you're just going to see that information grow. So it's still capturing data right now. It's processing all that. You can see it growing. It keeps on saving that. Now, one of the things you'll notice every time you open this up is when you're viewing those instances, the permissions, why name isn't the first item in the list? Why is permissions at the first item in the list? And that's because with POSH2 support, you do not get ordered dictionaries. So you can't reorder or set an order of an object or the dictionary or a hash table. None of that stays the same in POSH2. So POSH 3.0 and above is supported, and it will grab that information in a specific order, but because BluGenie is POSH2 has POSH2 support and above, ordered dictionaries or ordered objects are not initialized by default. So for here, we have our return. Again, we found 10 files. We did a recurse, use cache, signature, permission, so you can see all of the attributes that were processed with the command. It took 1 minute and 44 seconds to process all that data. Here you can see the hash information was not captured because this VMware vmuser administration.log is actually being used by another process. So you get real detailed information of the file and what's going on in real time. So now if we go back to the text document, you can see our GUID is finalized. 28K was the size of the file. Lots and lots of text in here. But all of it is captured to the machine. Now what you probably noticed is, well, let's say I didn't want this cache information. There's actually an attribute or a permission to use for that, and I'll show you that in 1 second. But here you can see that all of that data is here. Captured in readable format. Really, really easy to understand and view. You can keep it there for a later time. But one of the parameters that we did not use with this instance was remove cache. So remove cache will remove that file, but by default, cache is always left behind. And that's just to make it easy, so you always have a way to go back and grab information. Let's say you did a query on the whole machine, you grabbed all of the hash information, and you don't want to reparse all of those files. You can actually just go and grab that cache file and import it, and then do what you want to do with any kind of data manipulation that you set out to do. And then last but not least, we have a remove function. So we're going to pull the pattern txt and the exe. but this time we're actually not going to gather any of the permissions information. We're not going to grab the signature. We're only going to look for name. And this time we want to force a remove of those files because we know that if, actually let's change that even. Let's use the hash. So in this instance, we're going to use the hash where we do a search on the Windows temp directory. We're looking for the hash, the pattern that we know is a bad hash file. And if it's found on the machine, we want to not only log it, but we want to remove it. So for this instance, we are still going to output unescaped JSON so we can see it. And we're also now going to add the remove so we can see that data, or we can see that the file was removed. So now we're going to hit enter and process that information. All right, so we found two files that were that had the same hash pattern that we were looking for. Here's the pattern we were looking for. You can see that the name of the file was cwindowsTempSample.txt. The removed list or object now has items underneath. So you can see literal path was cwindowsTempSample.txt was removed. It was true. Is locked equals false. Path. Did it have a locked process? No, because it wasn't locked. It was on disk when it was searching, but again, it removed it. So if we go back to look for that file, we'll do that in 1 second. I want to make sure that notepad.exe was also removed. So here's cwindows temp notepad.exe, removed equals true. It was not locked. So now if we go and look for those two files, here's the cwindows temp. I'll refresh the screen. I'll go back in just to make sure. Both of those files have been removed. We can also do another quick search to see if we find any files. No items were found. So those items were cleaned. They were logged and shown to us in that last query. And now that hash, any files that had that hash identification have been removed and cleaned from the system. Now that we've tested that command and we know that this is the command that we want to run, and these are the values that we want, the only thing that we actually need to remove is the out-escaped JSON because we're not actually showing it to the foreground. We're actually sending this as a remote command. The easiest thing to do when you're running these commands is to literally just put them in a, you can see our string has single quotes. Any of our strings have single quotes. We just flip around the single quote to make the entire string a double quote. And here we can add the commands prefix. And this will actually add that command to our settings file. So now here's our command, and it's going to run get BluGenieChildItemList, search path cwindowsTemp, the filter type hash, pattern, remove. And so we can actually add, again, like we did. If you followed any of the other videos, you could see that we've added systems this way. So here we're going to add systems. We're going to do Windows 7 SP1001, Windows 7 SP1002, and our couple of Windows 10 machines. So we have our 4 computers, and again, we just type in run, and now we're going to get that particular command that's running our query. It's looking for that hash file in the cwindows temp directory. It's going to report it, and it's going to remove it. All jobs have completed. We can open up the log there. Under completed, we can pick our first JSON. So again, the Windows 7 SP1001 JSON, which we know from past sessions that it's a POSH2 machine. We're going to format our JSON data so that it's more readable for us. You can see that the command that was ran was commands. Post commands is empty. The command that was executed, the return for that, item list is the key identifier. And then we have our items. So our cache path would have been this if we created cache. We did not. Items found, null. Parsed 16 files, so we can see that it did look for files. At the end of the day, you want to see this file. You want to know, all right, I scanned 400 files and I didn't get any, so that means it's clean. If this comes up with 0, but you know there's files in that directory, something went wrong. We have start time, comments, found 0 items. Hash information that you were looking for was there, the path you were looking for, so on and so forth. And we would do that for the other items as well. So in this instance, we can tell this one parsed 12 files, still found 0. And again, there's the command. If it did find it, it would have removed it for us. So now we ran the BluGenie child item list on the local host. We identified a command that we know was valid. We found a search pattern that we know was on our local host. We tested it. We successfully added it to our commands section. We successfully deployed that to a handful of nodes throughout our network, and they returned clean. So that means that that specific file that had that specific virus was not identified on any other computers, and we are clean and ready to go. So this was a great test for BluGenie child item list. So thank you for joining me for this session. Join me for another session where we go into further details about BluGenie.